Okay, so now we're going to start our final section for the last unit test. So 7.6 has to do with solving equations. Notice we kind of skipped over 7.5. 7.5 is complex fractions. We don't do that in this classroom. So what makes this different than what we've been doing? The other ones we were multiplying or dividing or simplifying. You might be saying, well, is this the same thing as subtraction? No. And the reason why this is not quite the same thing as subtraction is because notice we have an equal sign. Remember, solving equations means that there has to be an equal sign in the problem. So every problem from 7.6 will have an equal. Now, how do you handle this? What we don't like is to have so many rational expressions or fractions. I have a fraction here, a fraction here, and a fraction here. So there is a way that we can get rid of fractions because our goal when it says solving equation is to get the letter B equal a number. The number could be a fraction or a whole number or a negative number, but our goal is to get B equal. So we don't want to have these fractions. So how do we get rid of fractions? And we only do this method if you see an equal sign. It is a lot of steps, so let's kind of go through them real quickly. So solving equations with rational expressions, you can see the first thing that you want to do is find an LCD. And you're going to use an LCD using all the denominators. So you can see in this guy we have 3 fractions. We're going to use all 3 denominators. Normally when we were adding 2 fractions, we didn't have 3 fraction bars. Here we have 3 fraction bars. Once you find the LCD, then what we're going to do is we're going to place the LCD in the numerator on the top of each of these fractions. And the reason why we do that is so that when we get to step 3, we can cross out part of the LCD with the denominator. Our goal after we do step 3 is that all the denominators will disappear, that we don't have any more fraction bars. So what we're going to do is then rewrite the problem, and by rewriting the problem, then we don't have to worry about fraction bars. We can then distribute and collect like terms to actually solve for the variable. Now for these guys, there could be 2 different types of variables. You could have just plain x's. If you have plain x's, then this is what is basically known as a linear equation. This is the stuff that we were using in Unit 1. Remember, we were saying simplify, labeling, moving, divorcing. Remember those 4 steps? You were getting all the variables on one side, all the constants on the other. The other way to do solving is if you have an exponent, like an x squared or an x cubed. If you have a squared or a cubed, to solve these guys, you can't do variables on one side, constants on the other. You actually have to do the factoring method. Now, how do you solve by factoring? We did that in section 6.7. What you want to do is get all your terms. That means constants and variables on one side. And then once you do that, then you're going to factor that side completely because all things will be on one side, the other side will equal 0. And so then what you want to do is factor and then take each of those factors and set it equal to x. Now this is a lot of steps, so let's go over the first step with you. It says find an LCD. Notice each denominator is a monomial. So you know, if it's a monomial, we need to factor them completely. To factor out 4, we know it's going to be 2 times 2 when you do a tree diagram. When you factor out 12, you know that's going to be 2 times 2 times 3. And then when you factor out 6, it's 2 times 3. So when you do an LCD, the only types of factors that we have are 2's and 3's. When you do the versus game, there's 2 here, 1 here, 1 here. Notice we're comparing 3 fractions now. So 2 versus 2 versus 2 versus 1. The highest amount looks like it's 2. Okay? When we do the 3's, we're going to look at each one. This one's 0, this one's 1, this one's 1. So then the highest amount, 0 versus 1 is 1. So our LCD is going to be basically 12. Now, once we find our LCD as 12, step 2. It says we're going to place that LCD in the numerator. Remember, that's the top of the fraction. And we're going to use parentheses to separate it from the numerator. So notice, for this b, you can either put in 12 if you're really good at math and go like, well, I know 12 can go into 4. Or if not, you can use the factored form. When it comes to variables, you're going to use the factored forms. When it comes to numbers, it's your choice. I'll just stick with the numbers just to show you how this works. So this means I have 2, 2, 3. Remember, 2 2s and 1 3. Then in this numerator, I put the LCD as well. 2, 2, 3. And then in this numerator, put parentheses to separate the numerator from the LCD. 2, 2, 3. Okay. Now what you want to do, after you put that on top and use parentheses to separate the numerator, we're going to cross out part of the LCD with the factored denominator. So notice I have a 4, a 12, and a 6. I'm not going to pay attention to those numbers. I'm going to pay attention to these factored forms. Remember 4 we said was 2 times 2. We said 12 was 2 times 2 times 3. And 6 we said was 2 times 3. The reason why we want to pay attention to the factored forms is because if you see one factor on top that matches one factor at the bottom, you can cancel out. See how like we have a 2 on top and a 2 on the bottom? They can cancel out. Or this 2 and this 2. Do that for each of the fractions. Go here. See, I have 2, 2, 3 on top. Notice on the bottom, I have 2, 2, 3 at the bottom. So everything cancels out. That's your goal, is that everything in your denominators will cancel out. Here, 2 on top was a 2 on the bottom. And a 3 on top was a 3 on the bottom. Now, notice we don't really have any denominators. We don't have any fractions that we have to worry about. It looks a little clunky though. So this is where I said, once you cross out, all parts of the denominators will cross out. Let's rewrite the problem as just a regular equation. You won't have any fractions. So what's left off here is this 3 and a b. What's left off here? Just the negative and the 7. Notice I do like to keep those parentheses because I need to see that this really means multiplication, especially when I come to this guy. Because if you don't use the parentheses, then you might have just 2b minus 4 and realize that you didn't need to distribute. In actuality, if you use the parentheses, you have to distribute. So make sure you bring those parentheses down. That's why we made it very important to separate the numerators with parentheses, because I'm going to bring it down. Notice there is no denominator. It's a regular equation. So now that it's a regular equation, step 5 says distribute to remove those parentheses. How do we distribute? Just multiply. You know that 3 times b is 3b. If you don't see a number in front to distribute, put in a 1. Make sure you distribute not only the number, but its sign. So you get -7. And in here, distribute the 2 out. So we'll have equals 2 times b, which you know is 2b. And then 2 times -4, which you know is -8. Once you have this, then we said the next step is collect any like terms on each side of the equation. Remember, we have an equal sign. When you have an equal sign, you know you have a left-hand side and a right-hand side. So focus on one side of the equation at a time and see if you can simplify. Remember, simplifying was basically get rid of the parentheses, which we did, and then collecting any like terms. This is a, remember, coefficient, variable, constant. So nothing like on this side. Once you're done looking to see if there's anything that you can collect on the left, see if you can collect anything on the right. Coefficient, variable, constant. So there is no like terms when you focus on one side of the equation at a time. So if there's no like terms, we'll just go to step 7. Solve for the variable. Do you have an exponent or not an exponent? If you don't have an exponent, then we're going to solve as a linear equation. Notice we don't have a b squared or b cubed. They're all linear. So then this is where we're going to do unit 1 material. Remember, unit 1 material says, okay, put all the variables on one side, put all the constants on the other. So remember, that was the simplifying, the labeling. Let's see, both sides have b, but this one has the greater amount, so this side be variable. This side must be constant. Move, you know that this 2b cannot stay on the constant side and needs to go to the variable side. This is where we do the additive inverse, opposite sign. Whatever you do to one side equation, you have to do to the other. They have to balance. Inverses cancel out. 3b minus 2b, positive and a negative, you remember subtract. You'll get 1b, or the same thing as just calling it b. And then you're just going to move the constant of negative 7 over here. So the opposite of a negative 7 would be to add 7 to both sides. So we get b equals negative 1. Remember, negative and a positive, you have to subtract. Who wins the tug of war? 8 players do. The last thing that we have down here, which you usually don't pay attention too much to, it says that eliminate any answers that would make the rational expression undefined if that answer is plugged into as the variable. What does that mean? That means think of what our original fractions were. Gotta go back to your original problem, the original fractions. Remember, we had a 4 here, we had a 12 here, and we had a 6. To make anything undefined, and that we talked about in 7.1, is if I plug this in the denominator, and the denominator will become 0, then this is an answer you cannot have. Because if it makes one of these fractions undefined, then you have to eliminate that as an answer. But notice, don't look at the top, just look at the bottom. There's no way you can plug in for b. There's nothing I can do to make this 0. 0, 0 at the bottom. So this guy is fine. You might be saying, well, what would be an example where it could be not good? That would be, let's say the bottom here was b plus 1. If this bottom was b plus 1 and I got this answer of negative 1, if I plugged in negative 1 where the variable is, negative 1 plus 1 is 0. No matter what's on top, this divided by 0 would make it undefined. So luckily, when you have all numbers like we had, we did not have to worry about anything becoming undefined. So our answer is b equals negative 1.